Okay, so let's look at the exercises from 7.3. First one I'm going to do is 3A. So let's go ahead and do a snip. And here's my clip. So here we do. All right. Thank you. I don't need to do that. I don't care about that because I know what I'm doing. All right, so here, let's see what we got here. Whoops, sorry. All right, so here it says, I want to verify some entries in the table by writing the symmetries in Tableau form and computing the composition directly. So here we have row 2, column 4. All right, so we're talking about a table. It's a composition table. We also call this a Cayley table. And we want to show that the entries of this table are correct. This table shows the result of a composition of different symmetries. So we need to go back to the page and see what's going on. All right, this Cayley table, 732, is a table involving some symmetries. We have row 1, row 2, mu1, mu2, mu3. And then if you look in the text, you can see that row 1 is rotation of a triangle by 120 degrees. Row 2 is 240 degrees. And whenever we say degrees, we mean degrees counterclockwise. Then mu1, mu2, mu3 are 3 flips. You have a flip around the 3 different axes. So here I have the, what do you call this? The Tableau form explicitly for all of these different symmetries. Now I'm supposed to verify the entry in row 2, column 4, I think it was. Let's look back and see. Row 2, column 4. All right, so row 2, column 4 is, row 2 is row 1, and column 4 is 1, 2, 3, 4. Column 4 is mu1. So I want to show that the entry here is actually correct. Now, the question is, does this correspond to row 1 compose mu1 or mu1 compose row 1? And you need to look back in the text to see which it is. Here it says that the row marked row 1 and the column marked mu1 corresponds to row 1, mu1. Okay, so I want to verify that row 1, mu1, row 1 compose mu1 equals mu3. So that's what I want to verify. Let's write that down just to make sure we've got everything. So we want to verify for 3A, we want to verify that row 1 composed mu1 is equal to mu3. Now I need to give the Tableau form for these 3 symmetries. Now, since we're doing symmetries on a triangle, every single one of these will have the form ABC on the top and then something else on the bottom. So row 1 is going to look like that, mu1 is going to look like that, and then mu3 is also going to look like that. All right, so they're all going to look the same. So in order to find out what the second row is for each of these tableaus, I just go back and look at the chapter and see what it says. Right, row 1, the second row is going to be BCA. So let's go back and fill that in. This here is going to be BCA. All right, mu1, should have left more space, but that's okay. Mu1, second row is ACB. Notice just the C and the B get flipped around. Mu3 is going to be BAC. The A and the B get flipped. Okay, so here's BAC. Now, It's very important, the order. Remember that rho 1, mu 1 means that we apply mu 1 first. Okay? And then rho 1. Okay? So what I want to do is find out what applying mu 1 first and then rho 1 does to each one of these vertices A, B, and C. So let's see what we can have A, and first it's going to go to mu 1, and then whatever that result is, it's going to go to rho 1. Or I might as well do all three because they're all three going to look the same. I want that for A, I want it for B, and I want it also for C. So insert space here. Okay. And let's go up. Give me some, come on. There we go. Okay. I'm going to want to do it for A, for B, and for C. So let's get a space for B here also. B, what does mu 1 take B to? And then what does rho 1 take the result to? C, what does mu 1 take C to? And then what does rho 1 take the result to? All right, so we can solve this by using the different tableaus. All right, A under mu 1 goes to what? Well, A goes to A. We might as well do all the U1s first because they're all in a row here. A goes to A, B goes to C, and C goes to B. All right. Now I want to see what rho 1 takes all of these to. Well, rho 1 takes A to B. Rho 1 takes C to A. And rho 1 takes B to C. All right. So what do I have here? I have ABC goes under rho 1 compose mu 1 goes to BAC. So I have ABC and BAC is my tableau, which is equal to mu 3. Okay, so I have verified that the composition of mu 1 and rho 1 composed mu 1 is equal to mu 3. All right, so you can do the other ones similarly. It should be a very straightforward process. All right, let me go ahead and do 11. So I need to give myself some more space down here. Okay, good. I have a good amount of space. And let me go back here to 11. And 11 is down here. And so we got a bunch of logos. So I think I'm going to have to copy the logos in order to refer to these. So here we go. And we're going to snip. Insert screen clipping. And here we go. And we're going to have to imagine the symmetries of these guys. Whoops. All right, let's see if we can get this over. Okay, I may have to redo this. This really got kind of messed up. All right, I think this, oh, all right, this one, we can just erase that. Oh, that screen clipping thing got messed up here. Let me just erase it and I'll redo it. All right, so let me just redo this tableau just so you can have the references. So we have ABC goes to BAC. So that means that rho 1 compose mu 1 is equal to, and that's equal to mu 3. Okay. All right, so now we've got our symmetries down here, and we're going to ask some questions about these. So basically, we're wanting to see what the different symmetries are. All right, let's see if I can move it up just a little bit. Like that. Okay, very good. All right, now let's copy the questions. And the questions I was going to do was C and D. So let's look and see if we can get those here. Okay. So let me go back to the page and I'll go to C and D. Okay. All right, let's snip. Oh, there it goes. C and D. All right, so we go here, go to, oops. Why isn't it going there? Okay, so we'll do insert. I think I'm going to have to click out of here or it's not going to work right. Okay, it's still in there. Let's try that. Okay, draw, oops, insert, screen clipping. And I wanted C and D. I'll insert those two. All right, very good. Okay. All right, for C. All right, for which logos do the set of symmetries include all the symmetries of the hexagon? All right, now let's consider what are the symmetries of the hexagon. There are lots of symmetries of the hexagon. If you read the chapter, you'll see the symmetries of the hexagon are 60, 120, 180, 240, and did I do everything right? It's all in 6 and then 300-degree rotations. And there are also 6 flips. So the hexagon has a lot of symmetries. All right. So so let's see if we can figure out which one of these have symmetries of the hexagon. Now, if you look at these, you can kind of say, well, which one kind of looks like the hexagon? And that's pretty clear. That's number 5. All right. So let's see first if this has all the symmetries of the hexagon. Well, if you rotate by 60 degrees, it's going to look the same. If you rotate by 120 degrees, it's going to look the same. I mean, basically, you have 2 hexagons inside of each other. And then also, if you do the flips, for instance, if I flip around this axis, it's going to be the same. So certainly 5 has all the symmetries of the hexagon. Now, if you try all the other ones, you're going to see that there are things that don't work. For instance, this one here, if you try a 60-degree rotation, then certainly 60-degree rotation is not going to make this diamond shape into a diamond shape. It's going to skew the diamond. So that one's not going to work. If you try this triangle and you do a 60-degree rotation, then this point is going to end up halfway in between the 2 points. Right? You've got a 120-degree rotation, but you don't have a 60-degree rotation. Here also, a 60-degree rotation is not going to work. 60-degree rotation is not going to work. 60-degree rotation is not going to work. So 5 is the only answer. Okay. All right, now, next one. Which logos have set of symmetries that are, this should be, this is a set of symmetries, which are proper subsets of the set of all symmetries of the rectangle. All right, sorry. All right, now what are the symmetries of the rectangle? If you go back to the chapter again, you're going to see that you're going to have 180-degree rotation. And then you've got the vertical flip, and you've got the flip about the vertical axis, the flip about the horizontal axis, and then the identity. All right. So you can say that if the object has more than 4 symmetries, it's certainly not going to work. So you can do this one by one. Certainly the triangle has a 120-degree rotation, which is not one of these. What about this one here? This kind of looks like a rectangle. If I do a 180, I'm going to get the same thing. And this one's kind of interesting. If you do a horizontal flip, it does work. But if you do a vertical flip, the vertical flip does not work. You can try it and see that actually, I'm not sure that I think the 180-degree rotation also doesn't work. I think it's just the horizontal flip that works. It's not the 180 degrees is not going to work in the vertical flip. Well, let's see. The SH, this one here, is not going to work, and the 180 is not going to work. So you can see how that works out. So this one does have symmetries that are a subset of the symmetries of a rectangle. So in fact, 2 is included in this one. This one here has a bunch of angles of rotation symmetry. In fact, 360 divided by 5 is going to be a symmetry rotation, and that's not one of the symmetries of the rectangle. All right, here, this one is kind of interesting. This one, let's see, does this one have a, this one's a little bit strange. Let's see what symmetries this one has. Does this have any rotational symmetries? Well, if I rotate this 90 degrees, then you can play around with it. Then this figure here is going to go to this figure here. This figure here, I believe, is going to go to this figure here. This figure will go to this figure here. So this does have 90-degree rotation symmetry, so that one's not going to be there. This one has 60-degree rotation, which is not there. How about this one? Well, you can think about this one, but 2 is certainly in there, and you can decide whether or not 6 is in there. But the other ones are certainly not in there. Okay, so go through and look at each one of these symmetries and see which ones meet the conditions that all the symmetries are also symmetries of the rectangle. All right? So that's going to be part 11, and that's all that I was going to do in this section. So you can have fun with that, see if you can figure those things out.